Right, so here's part C. I want to go back to the idea of 1 plus a half plus a fourth.
Okay.
It turns out this is a special case of something called a geometric series.
Yeah.
Okay, and just for simplicity, I'm going to say a geometric series is going to be 1 plus some number, it doesn't matter what it is, x, plus x squared, plus x cubed, plus all the way on forever, an infinite geometric series.
Mm-hmm.
So in this series here, 1 plus a half plus a fourth plus an eighth, what is x?
X is a half.
Okay, what's x squared?
So it's a fourth.
Is a half squared a fourth?
Mm-hmm.
What's x cubed?
An eighth.
Is a half cubed an eighth?
Yeah.
Yeah.
Okay. All right. Well, cool. So I am now going to multiply this series here by what seems like a strange quantity, just 1 minus x.
Okay.
Okay. Let's see what I get. Well, first, I've got two things I got to multiply by, so I'm just going to multiply by 1 first. And that's, what do I get when I multiply a series by 1?
You get the series.
1 plus x squared plus x cubed. And what about when I multiply by minus x? What am I going to get?
You'd get
Negative
the series, but
negative-
times x. So you'd basically get negative the series and then
minus 1.
this.
Yeah.
So
So
negative
I get negative x, that's minus x times 1. What's minus x times x?
x squared.
Minus x
minus
squared.
x squared minus x cubed.
Okay. And so 1 minus x times this series ends up equaling what?
1.
1. All that's left, everything else cancels. The x's cancel, the x squared is canceled, the x cubed.
Yep.
So that means, what does this series equal? What is this series? What's a simple?
1 over 1 minus
Yeah,
x.
this series itself, I can just divide by 1 minus x. I get 1 over 1 minus x. So that turns out to be a pretty simple formula for this series, and it just seems to be purely theoretical, right? It's just manipulating algebraic expressions, everything else cancels. And you get 1 over 1 minus x. So let's see what happens.
So let's see, x is a half.
So here x is a half.
1 over.
Let's see if it works. 1 over 1 minus a half,
It's 1 over a half.
which is
2.
2.
Mm-hmm.
Okay. Now how about a more complicated series? How about 1 plus a third plus a ninth plus
Alright.
27th plus 1 over 81.
So it'd be then we can reach the 3 halves because 1 over 1 minus a third, 1 over 2 thirds, 3 halves.
1 over 2 thirds, so this is 3 halves. So it makes sense that this would be less than 2, right?
Mm-hmm.
Because all of our terms are less.
Yeah.
And maybe we can figure out some sort of argument saying, hey, maybe we're going like, always closer, a little bit closer to 3 halves.
So let's see. So 3 plus 9. This series equals a half because 3 halves is 1 half.
Yeah, that's right.
So 1/3 plus a ninth plus
Very good observation.
that equals a half.
The third plus the ninth plus the 27th actually all the way to infinity equals a half.
Yeah.
It's kind of neat.
Yeah.
And we can look at it with other numbers too, except now things can get a little strange. Okay.
Okay.
The 1 minus 1 series. 1 minus 1 plus 1 minus 1 plus 1 minus 1.
You're multiplying by a negative 1 each time.
Right. In this case, our geometric series x is just minus 1. So this equals 1 over 1 minus 1.
1 half.
Seems to be 1 half. What do you think about that?
But what if your series, like actually it would be our series where this is 1 over 1 minus 1.
Ah, very good. So then I'm just multiplying each time by 1, right?
So that'd be
1 plus 1 plus 1 plus 1 plus 1.
That's 1 over 0.
This is 1 over 1 minus 1, which is 1 over 0, or
Which is weird.
undefined.
So this is undefined.
Yeah, this is undefined. That's a little tricky. But you've seen something written down that says, what does this series add up to?
Infinity.
Negative a half.
Negative a half. And that's a little bit more complicated step. Because our geometric approach to this series doesn't produce the other answer we're about to see on the screen.
So 1 over 0 is...
But I want to show you just one other thing, because we looked at this 99999 series, right?
Yeah.
So in other words, that series I can break it down as being 9 plus 90 plus 900 plus 9,000.
So you're multiplying by 10 each time.
Yeah, I'm multiplying by 10 each time, and I don't quite have the 1 plus, but I can factor out a 9. And I get 1 plus 10 squared plus 10 cubed, right?
Yeah.
And if I plug this into our formula, this should just be 9 times 1 over 1 minus 1/10.
So that's 1 over 9, 10. That's 10. That would be 9 times 10 ninths.
Yeah, so, well,
So
not,
it would be 9.
10.
yeah, 9 times.
So it'd be
Oh, sorry. I'm multiplying by 10 every time. I goofed, but I'm glad we caught it. It's 1 minus 10. It's 1 over 1 minus x. I'm multiplying by 10 every time, so I get 9 times 1 over 1 minus 10.
So 1 over minus 9.
Yeah, so I get 9 times 1 over minus 9, which
so
is
that would be minus 1.
minus 1, which is exactly what we found that this series equaled
Yeah.
before, right?
Mm-hmm.
Yep.
So that's strange. Now let me ask you, before we go to the computer screen, do you believe this? Do you believe this series, 9 plus 90 plus 900 plus 9,000, all the way for infinity adds up to minus 1? Do you believe that?
Mm-hmm.
You do?
Yeah.
Okay. Do you believe it?
Yeah.
You do?
Yeah, but if someone... Yeah, I believe it now, but no one's shown me another proof.
Well, what if we do the partial sum idea before we stop? 99. 999. Am I getting closer and closer to minus 1?
No, you're getting closer and closer to like 10, 100, 1,000, 10,000, 100,000.
In other words, what does it look like this is going to? Sum up to be
Infinity.
infinity.
Yeah. 1 with infinity, 0.
But I seem to be telling you it's minus 1, but you believe me, and you don't believe your own eyes, saying this is going to infinity?
Well, it's also the 1 plus 1 plus 1 plus 1 series seems to also go to infinity.
Yeah.
And, yeah.
So what do you think? Do you believe minus 1 or do you believe infinity?
I believe minus
Minus
1.
1.
You believe minus 1? Oh, okay. Awesome. Alright, so now we're going to look at some stuff on the computer screen and about what a mathematician has to say about this, okay?
Okay.